Welcome back, everyone. In this lecture, we're going to go over the solutions for the data visualization exercise questions. Let's get started. Okay, here we are at the exercise notebook. Let's go ahead and work through the solutions. First thing I need to do is just run these first few cells to actually read in the data file and check it out. So now that I have the data file, what I'm going to do is first create a scatter plot of the price versus carrot as shown below. Lots of different ways you can do this. Probably the simplest way is to use Seaborn. And what we're going to do here is say sns.scatterplot, and then pass in the columns carrot on the x-axis, and then y as price, and then we happen to call our data frame diamonds, so we'll go ahead and do that. Run it, and you should see the same results here. Keep in mind you'll need to add plt.show in case you're not running this inside a notebook. So as we mentioned, there's a bit of a problem here with this marker edge being too thick, and there's so many points on top of each other, it's a little bit hard to tell the density of the points. So what we're going to do is we'll take the same code, let me just copy and paste it, and then we're going to add in some parameter calls. So the first one is alpha, which is essentially transparency. If we say alpha is equal to 1, that's totally opaque. If we say alpha is equal to 0, then that's completely transparent. Recall that we have almost like 56,000 points here, so we're going to go quite transparent here, about 10% or 0.1. And then the edge color parameter, which you can either kind of Google search or it's actually mentioned here, edge color parameter, we're going to set that equal to none. And then when you run this, it gets rid of that edge and also adds in that alpha, so you can see points stacked on top of each other in a clearer fashion. So you'll notice that singular points are very transparent, and if we stack a bunch of them on top of each other, we can see there's a density of points here. Next, we wanted to make the previous plot larger. So for this one, you may have to have had Google searched a little bit or check out our reference notebooks. We're just going to copy and paste our first plot command, and then right above it, we can say plt.figure and then call fig size is equal to whatever you want. So to make it larger, I went ahead and said 12 by 8. And then we get a much larger figure as our output, which also helps again with the density of the plot points. Moving along, I wanted to create a histogram of the price column. So to do that, I went ahead and used Seaborn's distribution plot. And then we only pass in, since it's a histogram, just one column. So in this case, it's price. And also, I'll say KDE is equal to false. So if you run this, by default, you get a smaller histogram. You'll notice mine's a lot larger. So one way to fix that is just by, at the top here, saying plt figure, fig size is equal to 12 by 8. And if you ran that, you pretty much got it. But you'll also notice that in the actual output here, we're a lot closer to 0. We don't actually have any negative prices in our data set. So it doesn't quite make sense for our x-axis to show some sort of access to that negative range. What we'll go ahead and do then is, after this, we can set some x limits. By saying plt xlim, go ahead and start at 0, and then maybe go up to something like 18,000 as our max. And then we get this plot here. That's, again, optional to play around with, but it kind of makes sense for a histogram that only has positive values to just start it at x equals 0. Moving along, we wanted to create a count plot of the instances per cut type as shown below. This should have been pretty straightforward. We just call SNS count plot, say we want it on the cut column, and then after that, we just say our data frame is the diamonds data frame, and there we get this result. Similarly, for the box plot, what we can do is just say SNS.boxplot, and notice that the y-axis is price and the x-axis is cut, so we'll go ahead and define those as well by saying x is equal to the string cut, y is equal to the string price, and data is diamonds. So we run that, we get this kind of smaller box plot, so again we'll make it larger by calling plt figure beforehand, and then setting fig size equal to something larger, maybe 12 by 8, and now we get this nice box plot. For the challenge here, we want to see if you can figure out how to actually change the ordering of the box plot. So it's a common question I get from students, and I wanted you to try to discover this on your own, and the best way to do that is by actually checking the online documentation for Seaborn. So if you actually Google searched Seaborn box plot, went ahead and checked that out and open up Seaborn box plot, you'll notice that there actually is an order parameter, which is the order to plot the categorical levels. So you can see different examples here, but the main thing is to actually find this order parameter and then realize that it's a list of strings. So we'll come back here and see if we can figure that out. So we'll go ahead and say diamonds, and let's just get the actual values that are available to us under cut. And we can do this using a little bit of pandas by calling unique here. And now I get this list. So I'm going to just copy that list element of it. This could also be a NumPy array. And then say cut order is equal to that list. Now keep in mind, that's the default ordering: ideal, premium, good cut, very good, and fair. What I want to do is make sure my ordering kind of goes fair, ideal, good cut, very good, premium. So I'll go ahead and make that happen. So we'll take fair string, cut it out, put it here, and then we'll go to ideal, which is next, and then premium, we'll go ahead and cut that out, put it at the very end. And now here we have our cut order. Okay, so keep in mind, Seaborn kind of just automatically puts this in the best order it thinks possible, essentially what's most efficient in the background. But you can always specify the order yourself along the x-axis by passing in a string like that. And a good way to quickly get that string is by calling unique on whatever column you're working with. So just a couple of tips there. Next, we'll go ahead and say SNS box plot, same as before, X is cut, then Y is price, data is diamonds, and now order is going to be equal to this cut order list that we just made. And if we want, we can also play around with the palette, and I went ahead and just choose cool as my color string. You run that, and then you get back this. So that's exactly what we wanted. And keep in mind, if you want to make it bigger, you can just say plt.figure, fig size is equal to, let's say 12 by 8, and we get back the same results. Okay, if you have any questions, make sure to check out our solutions notebook. Coming up next, we'll begin learning about TensorFlow and artificial neural networks. I'll see you there.